if we were to deal with moles of substances, it's a much easier problem than if we were working with grams of substances. So in other words, for example, if your question was if 3 moles of nitrogen was reacting, how many moles of ammonia is formed? We know it's a 1:2 ratio, so you can tell it's a 6 mole ammonia production, right? But if grams are given, it's a very different issue. So what you have to do is use this grams of ammonia. So our question is, how many grams of nitrogen will react with 7.5 will react to produce 7.5 grams of ammonia. So if your requirement was to produce 7.5 grams of ammonia, how many grams of nitrogen would you use? So then what we have to do is convert this grams of ammonia to moles of ammonia. And then using the equation, convert the moles of ammonia to moles of nitrogen. You know it's a 1:2 ratio or 2:1 ratio. And this moles of ammonia you will now convert to grams of nitrogen. And those are the steps that we are going to do in the next slide. Okay, so we are starting with 7.5 grams of ammonia. We know that molar mass of ammonia is 14.01 plus 3 times 1.008, approximately 17.03. So 17.03 grams of ammonia are present in 1 mole of ammonia, and in this step we have converted from grams of ammonia to moles of ammonia. Multiply this by, from the equation we know that 2 moles of ammonia are yielded when 1 mole of nitrogen is reacting, and we know that 1 mole of nitrogen contains 28.02 grams of nitrogen. So what we have done is we are going from grams of ammonia to grams of nitrogen. So grams of ammonia cancels, moles of ammonia cancels, moles of nitrogen cancels. Here you will end up with an answer of 6.2 grams of nitrogen. So if we use 6.2 grams of nitrogen, we will get a yield of 7.5 grams of ammonia. What you have to remember though is there are 2 reactants in this reaction. Remember, there is hydrogen as well, right? So then what we talked about so far was we needed 7.5 grams of ammonia. How much of nitrogen are we going to use? Which is fine. In this case, what we have done is we assume that we have enough hydrogen to react with the 6.2 grams of nitrogen. What happens if the amount of hydrogen is not enough? Or what happens if we had enough hydrogen and we didn't have enough nitrogen? In other words, in the next stages for this concept, we are going to learn about how to work on problems when 2 reactant amounts are given and a certain amount of product is desired, or how the amount of one reactant influences the amount of product formed. There we'll get into the concept of limiting reactant and percent yield.